Hello viewers, welcome to the channel Amazing Civil Engineering Studies. Here we will learn about different concepts related to civil engineering. Time to enter the world of civil engineering. Please subscribe to the channel and press the bell icon for more new updates. In today's video we are going to discuss about determinate and indeterminate structures. What is a structure? Why do we need to do analysis on structure? Have you ever walked under a bridge or a megastructure and seen different joints between the beams and columns in the structure? Perhaps you've seen rollers and hinges and you have wondered if that is enough to support the structure. Isn't a fixed end more stable than a roller or a hinge? Well, the answer is yes. However, sometimes stability creates risk of more exposure to types of stress, such as thermal stress. Structure is an assemblage of a number of components like slabs, beams, columns, walls, foundations, and so on, which remains in equilibrium. It has to satisfy the fundamental criteria of strength, stiffness, economy, durability, and compatibility for its existence. Any structure is designed for the stress resultants of bending moment, shear force, deflection, torsional stresses, and axial stresses. If these moments, shears, and stresses are evaluated at various critical sections, then based on these, the proportioning can be done. An engineer's duty is to design structures in a professional, safe, and economical manner in order to fulfill the purpose for which it was designed in the first place. Evaluation of these stresses, moments, and forces and plotting them for that structural component is known as analysis. Determination of dimensions for these components of these stresses and proportioning is known as design. Structural analysis. Structural analysis is the calculation of reaction forces, internal forces, stresses, shear and normal, bending moments, deflection, angle of rotation, etc. on a given structural member, provided different forces are determined. Structural engineers make structural analysis in order to design structures to withstand the effects of possible forces on structures. Structure is generally classified into two categories as determinate and indeterminate structures or redundant structures for analysis of structures to find forces. Statically determinate structures are structures that can be analyzed using statics equations only, i.e., equilibrium in all directions. In some cases, statics, which means the sum of forces in any direction is zero, and hence, no acceleration is experienced, this means it's enough to analyze a structure. These structures are referred to as statically determinate. On the other hand, statically indeterminate structures can't be analyzed using statics equations only, they require other material properties, such as deformations, in order to analyze them. Redundant or indeterminate structures are not capable of being analyzed by use of basic equilibrium equations. Along with the basic equilibrium equations, some extra conditions are required to be used, like compatibility conditions of deformations etc., to get the unknown reactions for drawing bending moment and shear force diagrams. The structure can be called determinate if the equilibrium equation provides enough and sufficient condition for equilibrium. If all forces for a structure can be determined using equilibrium equations only, this structure is determinate. But if the unknown forces are more and can't be determined using equilibrium equations, then this structure is indeterminate. In general, we can determine if a structure is statically determinate or indeterminate by drawing free body diagram for a structure or part of it and comparing a number of unknown forces and moment component with number of available equation of equilibrium. For coplanar structures, we have three equilibrium equations. If n is the total number of parts and r is the number of unknown forces and moment component, then r equals 3 times n, then structure is determinate. r 3 times n, then structure is indeterminate. In two-dimensional statics, the summation of forces in the x and y directions, and the summation of moments in the z direction all must equal 0. In three-dimensional statics, the summation of forces in x, y, and z directions, and the summation of moments in x, y and z directions all must equal 0. For each case, a mathematical equation is formed. If the number of equations equals the number of unknowns, then the structure is statically determinate. If, on the other hand, number of equations. Some examples for statically determinate structure in the figure above. The beams number 1 and 2 are statically determinate structures due to the following reasons. Beam number 1, the number of unknown forces is 3 equals the number of equations is 3. Beam number 2, the number of unknown forces is 3 equals the number of equations is 3. Example of determinate structures are simply supported beams, cantilever beams, single and double overhanging beams, three-hinged arches, etc. Examples of indeterminate structures are fixed beams, continuous beams, fixed arches, two-hinged arches, portals, multistoried frames, etc. Special methods like strain energy method, slope deflection method, moment distribution method, column analogy method, virtual work method, matrix methods, etc. are used for the analysis of redundant or indeterminate structures. Let's talk about indeterminate structure in deep. Indeterminate structures. A structure is termed as statically indeterminate if it cannot be analyzed from principles of statics alone, that is, summation HVM is equal to 0 respectively. A statically indeterminate structure may be classified as externally indeterminate, example, continuous beams and frames. If a structure is externally determinate, then all of the reactions may be calculated using equilibrium alone. To calculate external determinacy, the following equations are used. Statically unstable externally, R less than 3 plus E. C. Statically determinate externally, R equals 3 plus E. C. Statically indeterminate externally, R more than 3 plus E. Where R is the number of reaction components, and E. C. is the number of equations of condition. Both of these are described in detail below. The degree of indeterminacy is given by the following equation. I E equals R, 3 plus E. C. Reaction components. In the equations above, R is equal to the total number of reaction components as shown in table. For multiple reaction points, R is the sum of all the components for all the reaction points in the structure. Support type schematics reactions. R. Roller. R equals 1. Pin. R equals 2. Fixed. R equals 3. Internally indeterminate, example, trusses shown in figure. If a structure is internally determinate, then all of the reactions and internal forces may be calculated using equilibrium alone. Internal determinacy is generally much more important than external determinacy in structural analysis. To calculate internal determinacy, the following equations are used. Statically unstable internally, 3m plus R. C. Statically determinate internally, 3m plus R equals 3j plus E. C. Statically indeterminate internally, 3m and R 3j and E. C. Where m is the total number of members in the structure, R is the number of reaction components, J is the total number of joints in the structure, and E. C. is the number of equations of condition. The meaning of R and E. C. are the same as for external determinacy. The degree of indeterminacy is given by the following equation. I E equals 3m plus R, 3j plus E, C. Members and joints. There is no specific way that a structure must be split into members and joints for the purposes of the determinacy analysis. Any division of the structure is okay as long as the members and joints are consistent with each other. However, joints should be placed at least at the following locations. Free ends. Reactions. Intersections of three or more elements. Both externally and internally indeterminate, example, trussed beams, continuous trusses. A truss is statically determinate, both externally and internally when A. All the reactions can be determined from the conditions of equilibrium, namely summation HVM is equal to 0 respectively, and B. The total number of members, M equals 2J3, where J equals number of joints. The truss shown in figure is externally indeterminate to 1 degree because the numbers of reactions to be determined are 3 and the conditions of equilibrium reduces to 2, namely summation V. M is equal to 0 respectively. This truss is also internally indeterminate to 1 degree because there is one extra member. Number of redundant member equals M. 2J3 equals 22, 2x123 equals 1. Such trusses can be analyzed by using strain energy method. Determinacy of beams for a coplanar, two-dimensional beam. There are at most 3 equilibrium equations for each part, so that if there is a total of n parts and r reactions, we have R equals 3n, statically determinate. R3n, statically indeterminate. Indeterminate structures effectively have more unknowns than can be solved using the 3 equilibrium equations, or 6 equilibrium equations in 3D. The extra unknowns are called redundants. The degree of indeterminacy is equal to the number of redundants. An indeterminate structure with 2 redundants may be said to be statically indeterminate to the 2nd degree. Examples showing determinate and indeterminate structure. Example 1. Classify if each of the following beams is determinate or indeterminate. If statically indeterminate, what is the number of degree of indeterminacy? 1. If n is number of structure parts and r is number of unknown forces. R equals 3n statically determinate, r 3n statically indeterminate. Here, r equals 3 and n equals 1, then here r is equal to 3, hence structure is statically determinate. 2. Fixed support with rollers. 3 roller support with hinges. Here, r equals 5 and n equals 1, then here r is more than 3 and hence structure is statically indeterminate to 2nd degree. Here, r equals 6 and n equals 2, then here r is equal to 3 and hence structure is statically determinate. 4. Fixed support with hinges. If n is number of structure parts and r is number of unknown forces. R equals 3n statically determinate, r 3n statically indeterminate. Then here r equals 10 and n equals 3, then here r is more than 3 and hence structure is statically indeterminate to 1st degree. 5 examples showing another indeterminate structure. If n is number of structure parts and r is number of unknown forces. R equals 3n statically determinate, r 3n statically indeterminate. Then here, r equals 10 and n equals 2, then here r is more than 3 and hence structure is statically indeterminate to 4th degree. Example 2. Classify if each of the following frames is determinate or indeterminate. If statically indeterminate, what is the number of degree of indeterminacy? 1. Then here, r equals 9 and n equals 2, then here r is more than 3 and hence structure is statically indeterminate to third degree. 2. Frame having roller, fixed support, and hinged support. Here, r equals 15 and n equals 3, then here r is more than 3 and hence structure is statically indeterminate to sixth degree. If n is number of structure parts and r is number of unknown forces, r equals 3n statically determinate, r 3n statically indeterminate. Difference between determinate and indeterminate structures. Determinate structures' equilibrium conditions are fully adequate to analyze the structure, while indeterminate structures' conditions of equilibrium are not adequate to fully analyze the structure. Determinate structures' bending moment or shear force at any section is independent of the material property of the structure, while indeterminate structures' bending moment or shear force at any section depends upon the material property. Determinate structures, the bending moment or shear force at any section is independent of the cross-section or moment of inertia, while indeterminate structures, the bending moment or shear force at any section depends upon the cross-section or moment of inertia. Determinate structures' temperature variations do not cause stresses, while indeterminate structures' temperature variations cause stresses. Determinate structures, no stresses are caused due to lack of fit, while indeterminate structures stresses are caused due to lack of fit. Determinate structures, extra conditions like compatibility of displacements are not required to analyze the structure, while indeterminate structures, extra conditions like compatibility of displacements are required to analyze the structure along with the equilibrium equations. Difference between determinate and indeterminate structures. No. Determinate structures. Indeterminate structures. 1. Equilibrium conditions are fully adequate to analyze the structure. Conditions of equilibrium are not adequate to fully analyze the structure. 2. Bending moment or shear force at any section is independent of the material property of the structure. Bending moment or shear force at any section depends upon the material property. 3. The bending moment or shear force at any section is independent of the cross-section or moment of inertia. The bending moment or shear force at any section depends upon the cross-section or moment of inertia. 4. Temperature variations do not cause stresses. Temperature variations cause stresses. 5. No stresses are caused due to lack of fit. Stresses are caused due to lack of fit. 6. Extra conditions like compatibility of displacements are not required to analyze the structure. Extra conditions like compatibility of displacements are required to analyze the structure along with the equilibrium equations. A statically determinate system is neither better nor worse than a statically indeterminate system. It may be stronger or weaker depending on the details of the two systems. Though look at the advantages it can provide. When we provide more support and/or member to structure than required for static stability, it makes structure indeterminate. By providing this excess member, it ensures stability and also increase stiffness of the member or structure. Such as in case of truss, we provide additional diagonal members to ensure stability. So, the advantages of indeterminate structure over determinate. Stresses in indeterminate are generally lower than determinate structure. See figure. Deflection in case of indeterminate structure is less than those compared to determinate due to greater stiffness. See figure. Statically indeterminate structure have capacity to redistribute the loads. If a part, or member or support, of such a structure fails, the entire structure will not necessarily collapse, and the loads will be redistributed to the adjacent portions of the structure. See figure. Method of analyzing indeterminate structures. Member flexibility. Direct stiffness method. Member stiffness relations. System stiffness relation. Moment distribution method. Principle of superposition. Compatibility equation and solution. Force displacement relations. Slope deflection method. Force method. Integration method. These methods will be discussed one by one in other videos. Thank you for watching.
Thank you for watching. Please subscribe to the channel and press the bell icon.